Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. A driver and a passenger are in a car accident. Each of them independently has probability of 0.3 of being hospitalized. When a hospitalization occurs, the loss is uniformly distributed on the interval from 0 to 1. When two hospitalizations occur, the losses are independent. Calculate the expected number of people in the car who are hospitalized, given that the total loss due to hospitalizations from the accident is less than 1. And here's the solution. The number of people in the car that are hospitalized has the unconditional distribution described as follows. And you will see what these probabilities P0, P1, and P2 mean from what is written here. So n is equal to 0 with probability 1 minus 0.3 times 1 minus 0.3. That means none of them ends up being hospitalized, and that's equal to 0.7 times 0.7, so 0.49, and we call this P0. N is equal to 1 with probability 2 choose 1, so two ways to do this, and times 0.3 times 1 minus 0.3, which is the same as saying 0.3 times 1 minus 0.3 plus 1 minus 0.3 times 0.3. That's equal to 0.42, and we call this P1. And n is equal to 2 with probability 0.3 times 0.3, which is 0.09, and we call this P2. And of course you can see that P0 plus P1 plus P2 is 1. Let x1 be the loss in hospitalization for the driver, and x2 be the loss in hospitalization for the passenger. The quantity we're looking for is the expected value of n, given that x1 plus x2 is less than 1. And that's equal to 0 times the probability that n is 0, given that x1 plus x2 is less than 1, plus 1 times the probability that n is 1, given that x1 plus x2 is less than 1, plus 2 times probability that n is 2, given that x1 plus x2 is less than 1. Okay, well that's equal to, well the first term is 0, so we can disregard it. And then for the other ones we just write out the definition of the conditional probability, and since it's conditional on the same event, it's the same denominator, and that's equal to probability that n is 1 and x1 plus x2 is less than 1, plus 2 times, from 2 times the probability in the previous formula, the probability that n is 2 and x1 plus x2 is less than 1, and the whole thing is divided by probability that x1 plus x2 is less than 1. Okay, we'll leave the top as is, and the bottom we write as probability that x1 plus x2 is less than 1, given that n is 0 times p0, plus probability that x1 plus x2 is less than 1, given that n is 1 times p1, plus probability that x1 plus x2 is less than 1, given that n is 2 times probability of p2. Now observe this, that probability that x1 plus x2 is less than 1, given that n is 0, is 1 because there are no claims, so their sum is definitely less than 1. Probability that x1 plus x2 is less than 1 given that n is 1 because one claim distributed uniformly on 0, 1 is less than 1 with probability 1. And the probability that x1 plus x2 is less than 1 given that n is 2 is 1/2 because the distribution x1 plus x2 is the sum of two independent, identically distributed variables uniform on 0, 1, uniformly distributed, right? And that distribution is symmetrical about its mean, and the mean is, of course, 1. It's the sum of the two means, because of the symmetry of the roles of x1 and x2 and their own symmetries about their common mean of 0.5. So this expected value we're looking for, E of n given x1 plus x2 is less than 1, equals 1 times p1 plus 2 times 1 half p2 over 1 times p0 plus 1 times p1 plus 1 half times p2. And now we just plug in those values. And we calculate this to be approximately 0.5340, which is answer B. Please remember this is copyrighted material. The problem itself comes from Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.